Hello, I'm Rick at Cogent Dynamics. A little nervous about this. I'm not very good at the video stuff, so we'll see what we can do with my phone. So we do motorcycle suspension. There's an array of different improvements we can make. Today, let's talk about the Honda Transalp. I've got one of the USA 2024 Transalp 750s and really enjoy it. We've offered the Dolomite shock, which there's quite a few folks that have those on their bikes already. And we're offering a brand new upgrade for the stock forks that's quite cost effective to modify what your normal stock internals are. For this reason, we'd like to go through what it takes to do in the case you would like to do a more advanced do-it-yourself project or have a local suspension shop, or we can do arrangements where these forks or the cartridges can be sent here for a turnaround. So let's get a start. Just as an overview, this is one of the cartridges, and we have both the left and the rights here for the Transalp. And I wanted to just point out a few different, the two fork legs, there's a cartridge, obviously one for the right, one for the left, and one of them is simply a hollow tube without any functional components, and it's helping to support the fork springs, and it's also doing the top out effect for keeping the forks in position when they stretch out. So there's a certain amount of positional compression damping that I'll get into, but this is one of the Transalp parts, and let's just go over what we have. One of the things when these forks are made, the production, of course, trying to keep the cost in check, there's minimal parts and minimal cost, but it is a true fork cartridge system. And I gotta say, I'm pretty impressed by the way the Transalp works, just the way the factory set it up. I'm a big guy. I'm 200 pounds easy and about 6'1". And I've been riding the bike. I don't have it loaded up. I ride it as a road bike and Forest Service bike so far. And I really enjoy it. It's comfortable, it's pretty fast, and I think the suspension's competent. I like it better. So the one I have on my hands has a, inside these fill ports, I can see the actual piston or valve actually for compression. And inside of here, we have a rebound valve inside of here. I'm gonna take, for the other leg, we have, this is for the other leg. This is what we have is just the inactive leg. And actually, if you could see inside of these fill ports, there is what I call a spindle that would normally hold a valve, and there is none. It just kind of, it goes right out through the other side. I'm not doing a good job, but it goes right through. There's nothing inside of this leg. So in either case, let's talk about what we have. In what we want to do is take apart the bottoms of these fork cartridges. I think taking the fork cartridges out of the fork normally would be pretty self-explanatory if we're getting to this level, but I'll go through that anyways. But there's a M8 bolt. This isn't actually the correct one, but it's the right size. That would be in the bottom of the fork, and we remove this, and once we have the caps off and the springs out, we'll have these cartridges come straight out of the forks. So today we're just going to discuss these elements and how we're going to do the upgrade. I like to kind of go through just some of the names and really basic stuff, just so you know what you're dealing with. I call this a damper rod. So this is a rod that actually moves the parts inside of here. And the caps for the forks would thread right onto this damper rod. So as part of this fork, we have a secondary positionally modified damping element, and it just uses this crimped on piece that fits into a conically shaped sleeve, and when that goes inside, it forces the oil, and when the oil's forced, it creates a lot more damping force, and it'll create compression and rebound. You'll find these forks on the Transalp is set up quite progressively, so the initial part of the stroke is going to be fairly soft and compliant, and if we hit bigger bumps, we're going to start increasing the force for the reason of damping, but also for the reason of the spring rate and the oil level, which there's a trapped air volume in there. So we won't get into that, but to keep this installation simple, instead of having threaded parts, we're using, Honda's using these, what I call staking. They're just denting. Looks like someone took a punch and just hammered this stuff in, but there's a machine that's doing this. It's not done by hand. And for some reason unknown to me, on many Showa forks, there's a small staking spot right there and 180 degrees out from one another. In order to take these apart, we'll have to remove that, and we'll get into that as part of this video. So why do they do this? For instance, an aftermarket cartridge for a fork. This particular one is our own Cogent Dynamics fork, and you see the damping rod. But these parts are made threaded together with all the pieces, which of course is really nice for servicing and the size of components and everything else, including the cost. But you could see, instead of just a staked in piece, we have the whole fork cartridge, and there's a piston for rebound and a compression valve. We call it a foot valve, but it will sit down here and function. And both of these, in both forks, when we build these, they'll have both of them will be fully active, so there'll be valves in each side. So both of these, or any of these functional cartridges, they work on positive pressure. So there's not, like in a shock where we might have negative pressure on the side of the pistons that can cause cavitation and things like that because of negative pressures. Well, we shouldn't. And generally, these on the rebound, for instance, there's a trapped volume of oil, and we extend the fork. The oil bypasses past the piston that's moving through some shims that creates the damping force. And as we go this way, there's a check valve that refills this portion of your cartridge with oil as we're going on compression, and the that pressure created goes across a set of shims. Actually, here's one of our own Cogent dolomite compression valves. There's a specific design of shims on this valve, and the opposite side of the valve will have a dropped element, but there's a check valve that opens up. So that's kind of how we're going. I have about 8 inches of travel total. It's a little less. It's in the probably closer to 7.5 inches. I don't recall what it says in the Honda provided information, but just looking at our forks, the springs, the stock springs are quite progressively wound. I would consider these to be dual rate, so there's a closer spacing of the wire on here, and this will create a softer feel and a lower amount of spring force during that portion of the travel. As these collapse, where these spring wires touch each other, then the main part of the spring reacts as if there were a straight rate spring. Yeah, well, this isn't. We actually designed some springs like this, and typically we much prefer a straight rate spring. Our dual sport bikes and these adventure bikes, we really have a compromise going on that we have to deal with all the time. And I've really come to really like the bike, and the reason I own one is it has a very compliant ride. I have other bikes that are dirt bikes, or something like my DR650, which is a dual sport bike that I would ride in more difficult terrain, where my Honda Transalp, it's a bike that's very comfortable on the highway and very comfortable on paved roads, and it's has a light feel to it, and no problem on Forest Service roads. No doubt my DR650, I am able to ride a little faster on rough terrain, and certainly my full-on dirt bikes, like our WR250R or my KTM 350 EXC, those bikes again are on the other end of that, where it works very well on rough terrain, and KTM's pretty miserable on any kind of pavement, in my opinion. But that's the spring, and we of course are offering a firmer spring for this that is straight rate. But at my weight, at 200 pounds, and my use, I'm very happy with these. I didn't feel like this was the important thing that I wanted to find for this bike's performance. I was still a little unhappy with the more jarring feeling of my Transalp hitting a sharp edge bump, like a baby head rock, or even a seam in bad pavement, or a pothole, that kind of thing. It's like it just really felt a little overly stiff to me, or jarring in those. Take another quick break. Yeah, if we're having to build the bike and keep the costs down, and have only one of these valves to provide compression damping, in my opinion, what's happening is not so much the amount of total force for damping from the shims. There's also what we call as a port restriction. So there is a size of orifices which push the oil past the shims, and once the shims are all the way open, it becomes a restriction from the size of the ports inside these pistons. And these are 20 millimeter pistons, as they are on these. That Cogent fork was a 25 millimeter. And in a lot of cases, we're having just a single piston on one side of the fork leg. We'll often see bigger ones, like a 30 millimeter size tube. So you can have bigger ports inside of these. Once again, Honda's not a $25,000 motorcycle. And some of those that are $25,000 a piece, they often need suspension work. So I think these bikes work really well. So no one should get all freaked out and you have to change your suspension. If you're happy with the bike, just love it and ride it, and that's what I've been doing. I've got these upgrades now, and trying to specifically address what I thought were the problems. And I've been very happy with a very simple and low-cost upgrade. Taking a break. One of the other benefits of opening these up, it allows us to do customizing valving. So a suspension shop, you know, if you're a rider and maybe there's characteristics that you like, but you would prefer a little stiffer feel or a little softer feel, these can be modified. We do a lot of work with the design of these parts, the stack of shims, our dynamometer that measures the forces at different speeds, and then we ride the bike. And that's, I think, ultimately all the measuring and fancy stuff. What matters is if you as a customer, if you enjoy the way the bike's working. And we found this to be a really good solution to have a ready to go. What we've designed here and set up, I think, is just right for these specific, this kind of specific application. In my opinion, if I'm going to do a great deal of work here, like trying to make a adjustable damping and having, you know, different springs, and we would just sell a complete replacement cartridge kit. It's quite a bit more expensive to do that, but these valves are well under $300 for the whole setup of two of these. And of course, these are made here in not only in the U.S. but right there in that machine. And some of the other parts are that's part of that assembly is also made in a different CNC company in Illinois. So I'm going to take a break now, and we're going to show how to. The next step will be to remove these dimples or the stakes to allow us to take this apart. I personally have not been able to understand why. I haven't been able to understand why that staking is done. There's quite a few other Showas with exactly the same design that they don't do those stakes. So my thinking is, maybe they just don't want that to rotate so it's more easily assembled without having the whole assembly spinning. And I'm putting a M8 cap screw in here, and I'm using a nut to tighten it, and I'm actually easily spinning the whole assembly right there in right inside the tube. So the stake is not stopping it from rotating it, and there's a wire retaining ring that is what's holding this on, and we'll see that here soon. But there's some other cartridges, including a really similar looking cartridge. It's a little bit shorter, but this is for the Honda Africa Twin. And at the moment, the set that I have on here, there is no valve. We have a very similar setup that will go on that bike, and these valves will go right into there. But to just illustrate what I'm talking about is there is no stake, and that stake or that dimple that's deforming the steel, that's really the most difficult part for a lot of people to get these apart. So let's get into it. All of us have different tools that are available for doing this. I'm going to caution that some of the things that you see me doing here or others doing here, make sure you feel confident doing this. These tubes are just a mild steel, I presume, and from what I can see, it's a drawn over mandrel tubing, and it'll drill pretty easily. The actual part, and we're going to take out, no we won't, we'll show you one of the other ones. This is a Honda spindle and valve that's in the active fork, and we're going to take that one out. But where that stake position lines up pretty closely with this groove, and what's good with having that groove in there is when we drill it out, we might over penetrate with the drill, and that's gonna help us. It won't hurt, and the kit is totally replacing this, so it's you can't really worry about scrapping that. I don't know if you're able to see from one of my focus shots here, but you can see the tip of a drill. Today what we're going to do is use a 5/32 drill bit, and I had to go look at the drill thing. I keep forgetting numbers in my head, but anyways, I'm going to start with the most basic practical means is just a hand drill. And we could, and I wouldn't do this on my granite table, but we could just hold that by hand and grip it. I think most of us working on these kind of forks would have a bench vise of some kind, because even taking the fork apart with a bench vise with some protected jaws, maybe some pieces of aluminum angle iron over the top of them, or whatever. And I'm about to show you this on one of our other workbenches that is for some of the rough stuff and welding and things like that. So it might be more similar to what folks use in a home shop. Let's go take a look. Yeah, no, I am not going to apologize for the mess, but I've got some copper liners that Wilton still provides these days in the US, and I really like them, but I think some of the simple aluminum jaws that you can use, some magnetic ones, or just use hard restored piece of aluminum angle iron and put on there, and just hold it and pay attention to that spot we're going to drill on, that little, if we can focus it or not, but there's a little divot, which is our stake. We're going to drill that. And now we want to grasp it on this portion. It's okay to go over here, but we don't want to grab it just over here. We don't want to just crush it because we want it to be round. It's important for the suspension to do that. So I'm going to set it up, and I'm going to keep it approximately square. And there's not a lot of force on there, but I don't want it to go away. You know, I don't want it to move out of there, but I don't want to crush it. So I'm going to put the drill bit on there, and I'm going to hold it, and let's see if I can get that going the right direction. And I got a higher RPM, a small drill bit. I don't know if you noticed, but you know, you can, I oversped the thing initially, but more importantly, once you get through there, you could sort of feel breaking through the wall of the steel. And if we push hard, it's going to leave a bigger burr, and we're going to have to deal with these burrs, both removing this and then, you know, installing the new ones. And the less hassle with that, the better. I'm going to show you another means of doing that. Okay, I know I talk too much, and here we go, but this is going to be the next better way to do this. And we just got a regular drill press and a vise, and I'm going to stand on a little bit of an awkward position here for me, but I'm going to do the same thing and centralize that close to top dead center as I can do it by micro eye here, and go ahead and just give it a light clamping force. Drill press table has automatically corrected the height, so I don't have to extend the quill as far. And I can pretty well see that I'm centralized pretty good there, and I'm going to start the machine. It'll be hard to hear over this, but it cuts easier, and I've got better feel. It's more straight, and I can feel that right there. It's just going through that wall, and hopefully that will leave a little bit smaller amount of burr. A lot of nasty little chips. So yeah, there we go. We got the drill press hole and the hand drill, and you could see the difference, but either way will work just fine. All right, maybe the best way to do this, and please give me a comment if you say this is the way that you always want to do it, but I've got a little bit smaller tool here. It's an 1/8 inch. We don't want to be so small that there's going to be some denting from the dimpling that they did to stake that. And we're going to turn this on and run the Bridgeport to so we have a nice clean hole, and the reason this is probably a little better is there's very little, there will be very little deburr to have to do afterwards. So I'm going to do the other one, which I'll probably edit some of this out. All right, let's we're going to remove the spindle. I call this part, and we have drilled those holes, and we're using an M8 bolt, M8 by 125, I believe, and the Honda supplied one's going to be quite a bit shorter. That's part of the fork, but I use a little longer one because we want to have some access in here, and we got to be able to get it out of there, which is really important to think ahead on that one, because we don't want to knock it down in here so far we can't reach it. Just make the project a little more than we want. I'm gonna rest this on my board, and I'm just going to right now. I'm just going to take this is a just a hammer that's handy, but it happens to be a leather one, and I'm just going to give it a little whack, and I'm gonna go ahead and push out a little more. It's down there. I'm gonna try to see if you can see right inside here, but now the groove, there's a groove and there's a metallic ring that holds it in place. There's a straight edge of this groove that makes it basically next to impossible to pry it out. So don't try to pry that ring out. Just take a little screwdriver, or if it'll do it, I'm just going to use my little special pokey tool, and I just go underneath it and just push it in. It's one of the reasons I want to sometimes put it in further than you think, and then I can just simply, without losing that, I'm going to pull it out, and there's our ring. And now, depending on how much of burr is, we're going to have some problems. Let's take this, put that down in further. Should have done that in the first place. Gives us more ability to kind of deburr that. To deburr that, there's a couple different ways to do it. We can use this little implement to kind of just sort of try to chip off any burrs. And the next thing, and you might choose to use like a Dremel tool with a abrasive round ball, and just carefully with maybe 2 sets of eyeglasses, if you're like me, and go in there and deburr that. Another way is either use a piece of wooden dowel, or if your fingers are small enough, you can just go right in there and use this to deburr it with, I've got, this is just a strip of 400 grit, or 320, something like that, and just make sure that's kind of cleaned out. And we're going to want to thoroughly clean these afterwards, because we really do want to have this clean when it's going together. Right now, not too worried, but there's really not a lot of trash in there. Now, if this is a pretty new bike, as there's more and more years and miles on there, be surprised how much more dirt there'll be. If I'm lucky right now, I'll be able to pull this out. And I'm not so lucky, and we're hitting, there's a groove in there that causes some trouble. And we can wiggle that, and it's not coming out too good. Let me show you a couple of tricks with it. All right, so this is a very, most basic hand tool way to do this, and this is cool. Set of vice grips that came off of, I don't remember, it was Imaging or Engineer Pass that we found it as a tool, and didn't see the riders, so I took it, and I got other ones, but it's kind of it's cool. And I don't need this to grab it very hard. I'm just gonna go ahead and grab that. Probably a little harder than that. And just by itself, we can pull that, but if that won't work, I can kind of use this pry implement here This is a high-tech pry tool. I might rotate that a little to let it go. I may have to re-grab it, but I'm going to just try it by hand. This is not the way that I do it, but I just want to make sure that we're doing this with basic hand tools, and that's not going to do it. All right, we're going to move into a more serious tool. So we are on a different bench. This is like where I'd rather be working, but so we could just kind of pull and just move it back in, and it's really got a good burr still. I could go back with a Dremel. Didn't want to make the horrible noise. I have a tool right here that I use always for this, and just give it a little bit of a pull. I could probably use my hammer on the vice grips, but we would, and there we have it. And we really didn't even score it or much of anything. There's a little bit of more of a burr there maybe, but yeah, it's all good. It's out, and we're going to clean this up and we'll install a new one. I'll consider part of this as the installation, but I really want to have that deburred all the way around, because we also want to make sure the new O-rings go in there without causing any damage. And what I showed was using sandpaper with my finger, which that's perfectly fine. We have a ball hone, and this is how I prefer to do it. And that's a pretty fine ball hone that's right for this 20 millimeter diameter. And, you know, here at the shop, that's what we do. All right, we're going to install one of our new Dolomite Cogent Dynamics compression valve in each one of these. I'm just going to illustrate the initial ones, but this first one. So I've got this deburred and I've got it cleaned, and one of the things we want to do is just take a decent, grease to that's compatible with O-rings. Just, you know, normal Buna N nitrile type of O-ring, and put a little bit on those O-rings, and if I still have some left on my finger, I'll go ahead and kind of hit that area. What I'm going to do, I'm about to make a mistake. I'm going to get that screw. Yeah, so when we put this in, and it doesn't matter which one, but we don't want to have them way down in there where we can't reach them, and we'll be very unhappy if they get down there. You'll figure out a way to get it, because this will push it in. But this is your active leg, so let's see if we can hear it. That's the check valve making the noise. Some customers will actually hear that and say there's something wrong with my forks, because that, you know, with oil going on in there, and there's a little check valve in there. So what I'm going to do is this nice lubricated one. I'm going to put that same longer socket head cap screw, M8 125, and I'm just going to slide it by. I'm going to be a little careful when I do this, because there's a groove for the snap ring, and I'm going to go ahead and push this in, and it goes real easy. But especially when I watch those holes, I don't want to have any nick whatsoever with my O-rings damaged. Especially that final edge. If you can see that little edge right there. I might actually rotate it just a little. There it goes. It's in, and I'll pull that in. All right, once that's in there at a reasonable height where I can easily retrieve it, I'm going to take that bolt out just so I have a little better handle on it. And I don't know if you can see that. That's a 1 millimeter diameter wire clip, and it's going to go inside that groove right there. And I think I can do it with my thumb. And we don't want it to come flying out because, trust me, I've lost them. And I'm gonna, yeah. It's easy to go through them. It's, you know, and then so I'm using my little proboscis here. And yep, good to go. We're back. I don't know if I can see any of my. Yep, it's all in that groove like it's supposed to be. And now I can take this screw and pull it out. And now it's seated. So this one is ready to go together. This can go back to the bike and for our riding pleasure. Quick comment that folks might mention. The other leg, which I have put together, there is nothing in there. It's just a dead unit. And so really the force of the oil that goes through these compression valves, there is a really just because of the check valve, the oil is only displaced by the diameter of the rod. So there's not a huge amount of oil flowing, but of course there is. And that's why even this is an inactive one, you're still gonna get the same forces from your compression valve. There's some higher technologies involved there because of the speeds and so forth, and you know, some of these dirt bikes will have what they call mid valves and things like that, but just in the basic scheme of things, just that's how it works. Yes.